What is the resultant force acting on a body that is undergoing uniform circular motion? To answer this question, we need to look at Newton's second law. Okay, consider an object moving in a uniform circular motion like this. From Newton's first law, we know that the resultant force acting on the object cannot be zero because the object is changing its state of motion. That is, its velocity is changing every time. So there must be an unbalanced force. Then from Newton's second law, we have F equals to ma. So from the acceleration that we have derived previously, we can actually get an equation for F, which is the resultant force acting on the object in a circular motion. Okay, so using F equals to ma, and your A will be v squared over r, so we get the formula mv squared over r. Or you can also express in terms of mr omega square. Characteristic of the centripetal force. The centripetal force is always directed to the center of the circle. By the way, the resultant force for object moving in circular motion, we call it the centripetal force. Okay, the centripetal force is always perpendicular to the linear velocity. The centripetal force is the resultant force. The magnitude of the resultant force must always be constant, because here we are talking about uniform circular motion. The radius is constant, the linear velocity is a constant, so the mass is also constant, so the F should be a constant. And the work done by the force is zero. Okay, the force does not do work because the object is going round in a circular motion, and the linear displacement, right, is never parallel to the force. Okay, so there is zero work done.